Hello everyone. Today we are going to look into this problem called rent from SPOJ. Okay, and so this is an interesting problem because we also have to use some kind of binary search over this, right? And yeah, so let us go and see. So what this problem essentially says is that we have got aeroplanes in certain configurations, right? And what it does is that this guy here is the starting time. The second column mentions the duration for which the aeroplane will run, and the third column mentions the profit that the aeroplane will make for running under this configuration. Okay, so what we need to do now is to maximize the profit. Cool. So let us see how to go about solving this problem. So the first part is, let me just write this configuration here. So it is, so start duration end and profit. Okay. So the first was 0, 5, the profit was 10. The second was 3, 7, the profit was 14. The third was 5, 9, the profit was 7. And the last one was 6, 9, and the profit was 8. Okay, cool. So now with that in place, let us see how we can actually run the aeroplanes. Okay, so assume that we are not solving the maximization problem. We are just trying to find out the configuration under which we can run the plane. So I choose to run the plane with 0. Okay, so it starts at 0 and it ends at 5th second. So the next aeroplane, can I pick this aeroplane here? The answer is no, because it starts at 3rd second while my aeroplane is still running. So I've got only one aeroplane in place, right? So the next aeroplane that I can pick is this 5, because it starts at 5, right? And it ends at 15. So sorry, it ends at 14, right? Which means if I have started from 0, I can work with this aeroplane. Okay, just this aeroplane. I cannot even fly this plane because it starts at 6, and if it starts at 6, my aeroplane number 3 was already flying. Okay, so what happens in second scenario, what we can also do is, okay, so in this configuration, that the profit that we would have ideally made is 10 plus 7, which is 17, right? So we would have made this profit here. So this is when we fly plane number 0 comma 2. Okay, when we fly 0 comma 2. Okay, now let us see what happens if instead we choose that we will fly 0, but we will fly 0 with this plane here, right? Because we have an option to select either this plane or this plane, right? So we can decline this plane, the plane on index number 2, and we can choose the plane on index number 3. So in this case, the profit would become 18, right? So 0 and 3 would make it 18. The another scenario could be, we can actually start with this guy here. We can start with this guy. So the plane starts at 3, it ends at 7. The profit is 14, right? The profit is 14, but we cannot choose any other plane now because there is no other plane that we can actually fly. So the profit is 14 in this case. The answer would be 18 because that is the maximum that we could make out of the configuration of 0 comma 3. So how do we go about solving this problem? Let us see that first. So first thing first, the most important part here is, how do we actually fly the planes? That is the most important part for this question. So I am going to write what are the end time. So the end time here is 5. The end time here is 10. The end time is 14, and the end time is 15. Okay. So what we will do is, we are going to sort it in the order of their finish time. Okay, we are going to sort them in the order of their finish time. So for this particular question, or for this configuration, it is already sorted in the order of finish time. So you see it in the ascending order, right? 5, 10, 14, and 15. So that is the sorting that we are going to do. And the reason why we sort it in terms of ascending order is because, so let's say this is the length of the time that we have. Okay, so what we would want to do is we would want to finish a job as early as possible so that we have maximum time left for us to pick the next job. If we sort it in, let's say, some random order, okay, and the first job actually finishes somewhere here, then we have wasted this entire time finishing only the first job, and we are left with very very small chunk of time to finish the rest of the job. So what we want to do is we want to finish the job as soon as possible so that we have like maximum time to take up new jobs. So which is why we have chosen to sort it in the order of end time. Okay, cool. Now let us make a table. Let us make an array. Okay, and see what happens. Okay, so this is 0th index, this is first index, this is second, okay, and this is third. Okay, so what happens at 0th index? The only thing that can happen is that we pick the plane which is coming first in the order of sorting, right? Because we know that this plane is also finishing the earliest. We know that this plane is actually finishing the earliest, right? So the profit that you are earning at index number 0 is simply the profit of the first element in the sorted array. So even it doesn't matter if this plane starts at 4. It doesn't matter if this plane starts at 4, but because this plane, or let's say the duration for that matter, is 1, despite the fact that this guy here, the second guy, is starting early, but it's ending late, right? So it doesn't matter what is the start time. What only matters is the end time here. Okay, so moving back to the original configuration, the original configuration was 0 and 5. Okay, so at 0th, or the first plane that has to fly, is going to serve us the profit of 10. Okay, now let us see how do we solve it for first index here. Okay, how do we solve it? So the plane, what is the plane that we can choose here? Let us see that first. Either we can choose this plane to run. So now for a moment assume that we have not run this plane here. Okay, so what we are doing is at index number I, we are definitely going to choose the index I. Okay, we are going to make a choice of index I and see if it is desirable to choose that particular value or not. So what we say that we have chosen the value, we have chosen the second plane to fly, and the profit that we have got now is 14. Okay, now this plane was actually starting at third second. This plane was actually starting at third second. So what we now need to figure out is there a plane that we had flown and that was completing its journey at third second? So in this case, the only plane that's before this is at 0th index and it is completing its journey at 5th index. So there is no such planes to see, right? So the only profit that you can make here is 14, right? Either 14, or now at this point of time, either you can choose this index number 1, okay, or you can choose this index number 0. But because the maximum value of 10 and 14 is 14, what we say is that in the configuration of first two elements of the array, we are going to run the second plane and not the first plane, because the second plane is going to fetch us a profit of 14. Okay, cool. Now that we have solved it for first two guys, let us try and solve it for the third guy. So the third guy by default is giving a profit of 7. Okay, and now what we need to do is there a plane, that is completing its journey at 5th second? Okay, or what is the latest plane that is going to complete its journey at 5th second? So the only plane that is completing its journey at 5th second is this, right? So the profit is going to be 7 plus 10, because now we would run these two planes 0 and 5, right? And it's going to be compared with 14 here. It's going to be compared with 14 here, because either the configuration could be to run 0 comma 2, or the configuration could be to run just the first plane, right? So in this case 17 trumps 14, so the answer here is 17. Okay, now let us go to the third index. Now in third index, the journey starts at 6th second. Journey starts at 6 seconds, it ends at 15 seconds. So the default profit that we get is 8. Now what is the plane? What is the plane that completed its what is the latest plane that completed its journey by 6th second, right? So the only plane that we get here is this 5 years. So the profit is 8 plus 10 comma the maximum of I plus 1, which is this guy. So this means that at this point we have a choice to run 0 comma 3, okay, and 0 comma 0 comma 2. So we have these two choices to make, right? But because this is fetching us a profit of 17 and this is fetching us a profit of 18, we are going to select 18, and the answer at the last value of the array is actually the answer to this question. So I hope this was the crux of the question. This was the crux of how we are going to solve this question. Every single time at row number I, we are going to find out the latest plane that is completing its journey at I or less than I, right? At I or less than I, and then we are just going to add the profit earned at that particular plane, by that particular plane, to the current profit, right? To the current profit, and we are going to compare it to the I minus 1, because this is another configuration, this is another maxima that we were running with. Okay, so yes, so that is in fact just a minor correction. So it's not the profit of that particular plane that we are going to add, it is the profit at the index. So the index here is 0, right? So this is the 0th index, so it is the profit that we have earned at that particular index that we are going to add, right? Because this profit here, this index here, actually has the profit of all the previous indexes, the maximum profit from all the previous indexes, right? And this is the latest running plane that is finishing before the desired start time of the current plane, right? So we are going to add the profit at this particular index. Okay, cool. So that was a minor correction. With that in place, let us go about writing code for this question. It is going to involve binary search. So, and this is a good example of how we use different algorithms and different technologies to solve a question. Okay, so I'll open ID1 and let us write this code. So the first thing is that we will make struct job, okay, and then we have int start, finish, and profit. So this is the configuration for a particular plane here, okay. And then once we have this in place, we now need to take our inputs, which is int number of test cases. So c in n while n minus minus minus. So now what we are going to do is we are going to make an array of our struct. So this is going to be an array of size. The size was okay, so the table size is also that we need to look here. So int size planes count, sorry, scene planes, and job array of planes, okay. And all that we need to now do is for int I equals to 0, I smaller than planes, I plus plus, job current, okay, and then scene current job dot start, current dot finish, and current dot profit, okay. And the last thing that we will do is current dot finish plus equals to current dot start, because what we have been given is duration and not the end, right? So array of I equals to current. Okay, cool. Now we have taken our input. What we need to now do is I'll create a function of comparing two jobs. Okay, so job J1 and job J2. And the way we compare is return J1 dot finish smaller than J2 dot finish. Okay, now the only function that we now need to make is int, or even before that, let us make the binary search function. So int find latest on conflicting job. Okay, and what we are going to get is an array of jobs and an index. So index up to which we have to actually search for. So int low. So this is a standard binary search code that I'm going to write. Int high equals to index -1. This is -1 here because we do not have to search for current index, but we have to search from 0 to the current index. Okay, so int mid equals to low plus high divided by 2 if array of mid dot finish is smaller than equals to array of index dot start. Okay, then if array of mid plus 1 dot finish smaller than equals to array of index dot start. Okay, so in that case low equals to mid plus 1, else return mid, and here return -1. Okay, and now the only function that we need to make is int maximize profit. Max profit, which is in which we are going to take an array of job and we are going to take the total number of elements that we have. So the first step is to actually sort, which is we are going to sort the array plus n, which is the size of the array, and then we have our own compare function. So compare. Okay, and now we are going to create a table. So int, so the array that we created, we are going to create equals to new int of size n, and in this table the 0th element is going to be array 0 dot profit. Okay, and now for int I equals to 1 to I smaller than n, I plus plus. So the current profit is int current index profit is equals to array of I dot profit. Okay, the index for latest non-conflicting plane equals to, now this is the function that we are going to use to find out the latest non-conflict plane that we ran. Okay, is so we are going to pass array comma I, and if we do not get any plane, which is if index, or what I'll do is I'll quickly write it as idx. Okay, idx is not equals to -1. Okay, so what we are going to do is we are going to add it in the current index profit. So current index profit plus equals to table of I, or table of idx, actually table of idx. Now all that we need to write is table of I equals to max of current index profit, or the profit that we had just before this. Okay, so I minus 1, and we are going to return table of I n minus 1 as the result. Okay, so this is the code that we have. All that remains now is to call this function, and the way we are going to call is cout uh, max profit, max profit array, and then we have planes. Okay, and slash n. So let me quickly now copy the input and put it here. Let us run it. Okay, so a couple of syntactical issue. Let us quickly fix that. So the first issue it says is that we did not put a semicolon there. We have not put a semicolon here, and sort was not declared. Okay, so maybe some of the imports are missing, and the way to solve it is simply import bit stdc dot h. Now our input is already given, so we are going to run it. So this is bits, not bit. Okay. This is taking too long to run. So it says time limit exceeded. So probably we have got something wrong in our binary search here. So this is looking fine. Mid equals to low plus high array of mid dot finish is smaller than array index dot start array of mid plus 1 smaller than array of start low equals to mid plus 1 return mid. And okay, sorry, so there is this else condition which thing here, which is high equals to mid plus 1. Well, that still doesn't look like. Oh, sorry, this is going to be minus 1. Okay, clear the output is going to be minus 1. We cannot go higher, right? This should be fine now. Yeah, so it says that the output is 18. So this was an interesting question because we had to apply binary search to figure out what is the, so if we are at any index I, what is the index that we are going to look upon, that we are going to, that is the sub problem to this current index. So that is where binary search came into place. With dynamic programming, because dynamic programming is a generic concept, it is not like a standard algorithm that's out there. There always has to be some sort of creativity that needs to be applied to solve the problem. And in this case it was sorting the input based on the end time, and then using binary search to figure out the index of the sub problem that we wanted to match against the current index, and then trying to solve the problem. I hope you had liked this video. Please like, share, and subscribe.